Good morning to everyone. My name is Adarsh Krishnan. I'm a principal analyst at ABI Research. And for those of you who are not familiar with ABI Research, ABI Research is a market intelligence and advisory firm. For the last 3 decades, we provided strategic guidance to enterprises needing market intelligence and advisory services on some of the most transformative and emerging technologies. This webinar on LPWAN Massive IoT, I will try and provide a snapshot of the LPWAN network technologies and in terms of how far they've actually delivered in their promise of enabling some of the massive IoT applications as of today, and also what the opportunities are, say, for the next 5 years. So to begin with my presentation, I'd like to start with the recent, or at least the progress we've seen in the last few years with regards to the network coverage and the maturity of the device ecosystem, which is a good indicator to point us to the near-term growth, at least for LPW network technologies. So in this slide, you can see as of this second half of 2020, cellular LPW networks, NB-IoT and LTE-M, have been deployed by over 120 network operators in almost 59 countries. And more recently, we've also started seeing LPW network roaming, especially with NB-IoT, which is currently available in over 20 countries, which is about 18 countries in Europe, the US, and even in China with the recent agreement with the MVNO ones. And this number is growing even faster. We believe it will grow faster going forward. So while there are telcos such as NTT Docomo in Japan and Dish Network in the US decided to stop their investments in NB-IoT, what we've seen is the operator investments in NB-IoT continues to grow. And today there are over 111 networks at various stages of commercial deployment, which is almost about 2.5 times that of LTE-M networks in the world. So that's cellular networks. When we look at the non-cellular LPW technologies, LoRaWAN, a key contender in this space, has seen rapid expansion of its global footprint. It's present in over 143 countries today. And although there are several nationwide and citywide deployments in Europe, France, Netherlands, Switzerland, being some of the examples, we're witnessing faster growth in private campus networks for LoRaWAN compared to public networks. So when we compare LoRaWAN with the next mainstream sort of non-cellular LPW technologies, Sigfox, on the other hand, their network coverage is based on exclusive regional partnerships with network operators, which means there is only one network operator, one network per country. So there are 70 networks, commercially launched or deployed in over 70 networks in 70 countries for Sigfox. When we look at regionally, Western Europe, which perhaps witnessed the most fiercest competition between cellular and non-cellular LPW technologies very early on, has perhaps, like, say, the strongest coverage compared to the other regions. That said, none of the LPW networks today can offer global coverage, but the footprint is growing quite rapidly across all regions. Now, the last few years, there was a strong initiative or push towards network deployments, but eventually we started seeing growth also in the device ecosystem. If you compare these different technologies, Sigfox, with an early head start in the market, perhaps has the largest portfolio of end devices. As of today, they have, like, say, about 400 devices that are commercially available. While LoRaWAN, where we started seeing a lot more rapid increase in terms of maturity of their device ecosystem in the last 12 months, has seen solid growth in their device ecosystem as well. There are over 138 devices that are certified by LoRa Alliance. And it's continuously growing. We're seeing rapid increase in terms of their device ecosystem over the last 6 months this year. Just to be clear, these numbers in terms of the devices, both for LoRaWAN and Sigfox, excludes the sort of double counting of devices with where the same devices with maybe regional variations are actually. We try to avoid that. So these are just the individual devices available in regions or multiple regions. Now, finally, when we look at cellular LPWA device ecosystem, they were a little bit late in the market with both the network rollouts. But over the last, say, about 6 to 12 months, we have seen rapid growth in terms of the device ecosystem for cellular LPWA as well. Asset trackers have been, like, say, the biggest has the biggest share of the cellular LPWA devices and accounts for almost 75% of the devices available today. So with that, I'll go into the next slide, which talks a little bit more about the cellular and non-cellular LPWA IC shipments. Here we're talking about non-cellular LPWA IC shipments. And as you can see in the chart, LoRa in the last 2 years has LoRa shipment of ICs have grown rapidly over the last few years. And you can see their year-on-year growth has been almost about 35 to 40% over the last 2-3 years. And now there are several factors driving this growth, but most important one in the past has been driven by the demand for LoRa chipsets in China. And in the last few years, we've seen support in China, starting with ZTE, who deployed networks in over 50 cities, and later with tech giants support, like say, support from tech giants such as Tencent and Alibaba driving this demand as well. However, with the US-China trade tensions and in 2019, the massive push for NB-IoT by telcos in the region, and then subsequently followed by the COVID-19 pandemic, they've all sort of had a negative impact on the demand for LoRaWAN in China. We've seen the demand starting to soften a little bit more in China over the last, say, 6 to 12 months time period. But what's happening is now you're starting to see the demand from Europe and US starting to pick up for LoRa. On the other hand, when you look at Sigfox, Sigfox has a fairly simple protocol stack, and it can run on most of the existing commercially available gigahertz, sub-gigahertz chipsets. And last year, they were able to break that sort of hardware barrier, that sub-$2 modules. That was actually, like, say, a really attractive, that made it the hardware, from a hardware perspective, it made it a very attractive solution in the LPWA space. Sigfox, in a way, continues to be ahead of its competitors in breaking the hardware cost barriers that are critical for IoT adoption. And more recently, they actually certified a I think it was a 20-cent radio module that actually can work in a Sigfox region. Now, when we look at another reason why we are seeing, like, say, growth for LoRa is also some of the we're starting to see how system-on-chip designs that houses maybe a LoRa radio can actually support multiple protocols, including Sigfox and other proprietary LPWA protocols, and even wireless M-bus, which is used a lot in the smart metering projects in Europe. Now, connectivity hardware vendors are trying to solve the issue of having a single SKU hardware for multiple protocols and that can actually operate in different regions. STMicro's recent STM32 SoC is an example of such a product. Now, when we talk about the proprietary LPWA technologies, they are, in a way, sort of losing share to some of the more mainstream technologies. However, there are other emerging LPWA open standards, such as the weightless, backed by weightless SIG, seeing some traction in the APAC region. MIoT, promoted by the MIoT Alliance, is also looking quite promising in the, especially in the industrial markets. When we look at the cellular LPWA module shipments, in this slide, we're looking at NB-IoT and LTE-M. Most cellular IoT devices today use modules in their hardware design to fasten their time to market. So you see it's a good metric to indicate the growth in technology adoption. By the end of 2019, there were over 45 million NB-IoT and LTE-M modules shipped, and we expect that to grow to over 350 million modules annually shipped by the end of 2024. Chinese module vendors have nearly 80% of the global cellular LPWA module, and this is driven by, like, say, also the demand for some of these modules in China itself. Now, there is an increasing pressure also to reduce the cost of modules in the last few years. We've seen module costs come down by almost 40 to 50% year on year, and today we see NB-IoT is available, like, say, at sub $5 and LTE-M at, say, around $9. But this is still considered a little too high for some of the more massive IoT applications. And I think there is more scope for these prices to further come down. Now, looking at the LPWA network connections by IoT applications, I'm just showing how they are similar in a way for both cellular and non-cellular LPWA technologies by vertical application, where smart metering is still one of the biggest vertical use case for these technologies, where in non-cellular LPWAs has had, like, say, it goes back, like, say, almost a decade, where you have your proprietary solutions from the from vendors such as Census, FlexNet, and the others offering these solutions. And we're starting to see also cellular technologies initially started off with connecting smart meters. It could be in China, it could be in Europe and other regions as well. Followed by that, we have asset tracking, which is again, like, say, one of the bigger use cases for both cellular and non-cellular LPWA technologies. And then you have aftermarket telematics, which is a little bit more on the stolen vehicle tracking application for some of the proprietary LPWA technologies. And then smart buildings is, like, say, a big vertical use case for cellular IoT applications or cellular LPWA technologies. I'll go in a little bit more deeper in these use cases in the next few slides. So if you look at the smart metering application, meter to cash is still the #1 use case driving utility smart metering rollouts. This includes data collection or automated sort of data collection processes, customer billing management, experience management. And this has been, like, say, more prominent with, like, say, the early deployment of smart electricity meters. But you're also starting to see this with the water sector, which is expected to see the most growth in the next 5 years. When you look at the water meters, it's a little bit different from your electricity meters. Water and gas are battery operated devices. So what we're looking at is, like, say, the use cases or the applications are limited in a sense to more meter to cash applications, but also leak detection. So in regions, we've seen water metering being used to target non-revenue water, which in some developed economies can be almost 20 to 30% of an issue. Like, say, 30% of the water distributed is actually, like, not built. So there's a lot of leakage, and they're trying to, like, say, cap that, like, say, by using meters and also other sensor devices across the network. Now, when you look at the market, as I mentioned earlier, proprietary technologies from meter vendors have been have actually continue to have a big share of the market. But we're starting to see the shift from proprietary technologies to more mainstream technologies, and we've seen that more recently with LoRa being used in China. We've seen technology vendors or meter vendors like Suntront and Ningbo using LoRaWAN and shipping meters in the millions already in 2019. And we've also started seeing cellular LPWA technologies, especially LTE-M, being used in North America, in the US, and also in Europe, where we've seen projects like, say, from Proximus using NB-IoT in Belgium. In Sweden, E.ON deploying NB-IoT smart meters using a Landis & Gyr devices. And then also in the UK, there have been more recent announcements from Vodafone using NB-IoT to connect meters and other sensor devices in their projects with Southeast Water. And more recently, again, BT announcing that they will be using NB-IoT network to connect the utility infrastructure for Yorkshire Water. So we're seeing overall there is good traction for both cellular and non-cellular LPWA technologies across different regions. That was, like, say, the biggest market, and it continues to grow, but the growth is a little bit more slower compared to the other IoT applications, because smart metering projects typically there's a lot of preparation before they go for these large scale projects, right? What we're seeing is, like, say, with asset tracking, and here we're referring to more location tracking of just non-powered assets. In 2019, there were less than about 18 million trackers using LPWA in 2019. But we expect this market to really explode in the next 5 years. And we expect there will be nearly, like, say, about 600 million tracker devices by the end of 2024. Asset tracking using wide area networks in the past have been sort of limited to tracking high value goods. So you'll see that in pharmaceutical, in healthcare, life sciences, and also maybe tracking maybe containers and the others. However, more recently, with the variety of devices, the availability of LPWA networks, have resulted in increasing demand across industries for more granular level visibility of tracking, like say even medium and low value assets. So what, and especially like say now with the COVID-19 pandemic, what we've seen is there is even more, it's kind of shed light on the complexity and the fragility of the global industrial value chains. And what we're seeing is that asset tracking will play an important role both in the recovery of businesses post-pandemic, and also like say, as we see the shift from your traditional linear supply chain models to more circular supply chains, where we see there's a growing emphasis on reverse logistics, and a data-driven supply chain will play a critical role in enabling this. So among LPWA network technologies, we've seen Sigfox, again, with its early head start, has had an advantage in early, with both in terms of the technology. It supports global roaming using its Monarch services, which allows radios to, the devices to switch radio frequencies based on the regional variations in ISM band. And they also have a fairly good device ecosystem, breaking down the cost barrier by for trackers to under $15, and that can operate for about 8 to 10 years with full autonomy. LoRa, on the other hand, has been tracking assets largely within campus networks. However, with some of the network operators in Europe offering regional roaming, we've seen regional roaming for LoRaWAN coming out in 5 European countries. So you have Swisscom, Obgenius, KPN, Proximus, and Digita in Finland that have actually that offer roaming in these regions. So you are starting to see more wide area network based tracking for assets in with using LoRaWAN as well. Now, talking about cellular techs, while cellular LPWA have been available for the last few years now, and it's still like say one of the largest, it has like say a large share of the devices available that have enabled by LPWA, cellular LPWA technologies. It still has like lesser traction because of one, lack of coverage and availability of network roaming before. And typically what they've used is a cellular LPWA in regions where they have connectivity, but then when it starts roaming, it switches off to like say about 2G, 3G, or maybe even LTE. This made it like say its use cases were actually limited. One, it was expensive, and two, when you're actually switching between two networks, it also makes it a little bit more power inefficient. So the use cases were limited to say tracking use cases where for a few months or maybe 1 or 2 years at the most. However, with the network coverage growing, roaming agreements coming in place, we're starting to see NB-IoT becoming an increasingly viable alternative to replace sort of earlier 2G, 3G based tracking devices. LTE-M also had early traction in the US, where you saw companies like Calamp and Zergo come out with trackers using LTE-M. And more recently, we are seeing some use cases coming from, for example, Vodafone and their ARM, an ARM partnership developed a tracking device, which was a smart label, and this was used to track packages for Bayer. There was also Core Connect with in the US coming out with their Zenith trackers using Sequence Monarch and PIT chipset, and which uses like say the POLTI geolocation technology. They're actually starting to add a lot more. All the pieces of the puzzles are coming together, and we see this really starting to take off even for cellular LPWA technologies. If you look at the vertical industries, aerospace and automotive has been like say some of the early adopters, but we see this demand going across vertical industry. We see like say, oil and gas, pharmaceutical, tobacco, retail, even third-party logistic providers starting to come up with solutions that can leverage LPWA technologies. So looking at the overall IoT market, we see the service revenue opportunity for LPWA will grow from about 9.3 billion in 2019 to about 58 billion in 2024. Revenue from device and application platform, professional services, and data analytics will actually account for about 80% of the revenue share. While currently, like say, device and application platforms have the largest share, we see data analytics will have the fastest growth rate, surpassing the others during the forecast period. Some key points I'd like to mention here is Supplier diversity and offer complexity continue to be a big barrier when it comes to IoT adoption. And while IoT marketplaces and advisory services are becoming more common, particularly amongst industrial suppliers, supplier categories are verticalizing to differentiate and break through the different IoT options. And finally, one thing we've seen is IoT platform supplier base is not consolidating, but it's actually like expanding to suppliers in all parts of the value chain. So it's becoming a little bit more complex. Finally, to conclude, LPWAN network technologies are growing at a fairly strong pace, and what we thought was what we estimate is accounts for about 10% of the wide area connections in 2018 will grow to about 30% share of the wide area network connections in 2022 and 51% by 2024. Metering, while it's the biggest opportunity, what it's also doing is it's enabling as an anchor application to enable other smart city applications. We've seen this with 15.4 based solutions where maybe an operator or a utility deploys a 15.4 based solution, but then starts also using or reusing that network to also connect street lighting, parking, and other smart city applications. We see that extend, like say, also with some of these other more mainstream LPW applications. Connections from asset tracking is expected to grow the fastest during the forecast period, and it'll surpass smart metering by 2023. And finally, when it comes to network connectivity, one thing to watch out for is also LEO satellite-based low power sensor to satellite connectivity technologies. You have a really strong ecosystem developing with the likes of Hyber, Sigfox with its partnership with Eutelsat, LoRa WAN with Lacuna, Swarm, and the others. You have Skylo, which is actually offering NB-IoT based solutions. They're all actually like say, enabling what we call this low power sensor to satellite connectivity, which will provide that ubiquity in terms of IoT connectivity to connect sensor devices. And that's really going to also deliver in some vertical industries, especially in agriculture, maritime, oil and gas sectors, but it'll also, like say, drive use cases in asset tracking as well. So with that, I'd conclude my presentation, and I look forward to your questions.
So we have a question from Andrew Weston, and he asks, how available is EU ICC-based permanent IoT roaming for NB-IoT and LTE-M across the world?
Sorry, can you just repeat that?
Yeah, I know, it's quite a tricky question. So how available is EU ICC-based permanent IoT roaming for cellular IoT across the world, both NB-IoT and LTE-M?
It's not available at the moment, right? And it will happen only when you start, when the operators start enabling their roaming services globally. As I mentioned, this is currently available only in 20 countries. And we are seeing initiatives both at GSMA that are working with the operators to fasten this process, but we're also seeing initiatives by the operators itself to fast track their agreements with other operators to enable this. So it's going to take some time, but I think it is on track to grow.
Okay, so the second part of Andrew's question is, who is leading in the number of EU ICC integrations? So is there any one you'd particularly highlight there?
I think most of the vendors are actually enabling this at the moment. We've seen, I can't really like say, name vendors on the top of my head, but we've started seeing that traction at least in this year. This year has been like say in a year where we've seen solutions come out into the market. What we're seeing is like say also ISIM based solutions will hit the market. We've seen the Vodafone ARM solution for smart labels actually uses an ISIM based solution. While there is like say still talks about the standardization of that particular of the ISIM solution, there are again initiatives from the operators that are fast tracking this process, and solutions are actually like say already available. We see that the smart label solutions have already gone into large scale pilot. I think we'll see 20,000 devices being tested this month, and Bayer claims that they will have about 5 million or sorry, 10 million devices by the end of 2025. So that's another area we see growth.
Okay, thank you so much for your time and your help, and a really interesting presentation there. Thank you so much.